Hello, everyone. This is Mr. Castillo. Hello. Welcome to Thursday, August 27th. Now, today we're going to do a little lab because it is Thursday. And so we have a little lab demo. All you really need for this lab demo is the dice, but not just one, three dice. Okay, I don't think you can see that. Oh, here. Three dice. All you need is just three dice right here, right? Now, if you don't have dice, it's okay. I'm about to put you a little link on this next note where you can actually go to it. Okay, so let me put the link. Boom. Yes, if you've clicked on the link, you should have clicked on to something that looks something like this. Let me make myself a little bit smaller. Like this. And this can actually help you with your link. Help you with the lab today. There are lab demos, a dice roll simulation, and you can go from three dice to two dice to even one die. Okay, so you can actually do that and with that in case you don't have dice lying around. Okay, dice rolling around. Funny joke. Okay, so let's get started with this little demo. Like I said, you only need three dice. We're gonna start with one though. Now, dice is a very good chance object. It's an object about chance, right? You have a dice right here, and you have how many sides? You have 6 different sides, right? Now, for this, since we have been learning about data representation, gathering data, and how to interpret that data from a table to a graph to a figure, and how to use CER statements in order to be able to eloquently answer a question, right? So, before we get started, I have my first question for you guys. I have my notes right here, so just don't mind them. First question is, what does CER statement stand for? What does CER stand for? Correct. It actually stands for C, claim, E, evidence, and R, reasoning, right? Now, for a second question, what is a claim? C is claim. What is a claim? Yes, a claim just answers your question. Good job. Just answers your question. How about evidence? What is an evidence? Exactly. Evidence is proof that supports your answer. Evidence is proof that supports your answer. And last one, what is reasoning? Good job. Reasoning justifies your proof. Reasoning actually explains why your evidence is supporting your answer. Kind of like a little like a trickle down effect, right? So we got claim, then we got evidence, then we got reasoning, and it all stack up on top of each other. Very good job. Now, what are the 3 main types of data representation that we will be using in physics? What are the 3 main type of data representation that we'll be using in physics? Correct. They are the table, graph, and figures. As you can see right now on my screen, I have a table right here, and then you will soon see a graph right here. We can't see it yet because we don't have data. And in the end, we have a little figure of our CER statement, putting everything together. So yes, we have 3 different types: the tables, the graph, and the figures. Awesome. Now, I said let's just get started, right? I mean, let's just get the show on the road. The very first thing you want is actually this link. My bad. This link right here. I'm about to put this link up here. Make a copy so you can actually keep track of your data. Okay. Boom. You should have gotten this little link right here, the Rolling Dice Demo Data Tracker. That's a mouthful. RDDT. Rolling Dice Demo Data Tracker. Try saying that like super fast, like 5 times. But yes, that is what you're doing. Okay. So we should be right here. Now you can edit this section right here, but you can't edit this part right here, our output. Okay. So we have a table right here, and we have been learning that there are 2 parts to a table. Well, technically 3 parts, but 2 main parts, right? And the third part is basically the titles, right? So we have our title right here. It's always going to be there. Every single data representation should be titled, whether it's a table, a graph, or a figure, they should all be titled. So this one is called the rolling dice probability, and in parentheses we have 1 dice. And then the next one we have the same thing, but now we have 2 dice. And on this one we have the same thing, now we have 3 dice. So that's the title of our table, right? And then in every table we have an input, and we have an output, right? So for our input, what's another way of describing the input of a data representation? Yes, there's actually correct. There are very different ways. There are the x-axis on the graph, It could be the independent variable, also known as what we are testing. What are we testing, right? Now, what is another way to describe the output? What's another way to describe the output? Correct. Another way to describe the output is the y-axis on the graph, or it can also be your dependent variable, which is what you're recording. What are you recording? What are you measuring? Okay, so we have input, x-axis, the independent variable, and what we're testing, and then we have our output, the y-axis, the dependent variable. What are we recording / measuring? Okay, great job so far. Hopefully, guys. So let's start with the first die. Okay, so our goal is to roll this dice 20 different times and record how many times it rolls that certain number. So with one die, we only have 6 possibilities, right? We have 1 through 6. 1, 2, 3, 4, 5, and 6. As you can see right here, we're testing the number rolled. Since we only have one die, we only get to do it 6 times. There's only 6 different possibilities, right? So in the frequency rolled, you're actually going to measure what those numbers are, right? So let's do that very quickly. I have like a little cup so I can keep myself organized. So I can just like keep myself organized as I shake it. And when I shake it, I'm gonna like flip it. Oh, that didn't come out right. When I shake it, I'm gonna flip it over, and that way I can just see, boom, what number it rolled. Just a way to keep myself organized. Okay. So let's try it one time. Let's see. We're trying to do this 20 times. 20 times. How many times are we trying to roll it? Exactly, 20 times. Here's my first time. I have a 3. So what I'm going to do, I'm going to go to where 3 is and just put a 1 there because it got rolled one time. And as you can see, as that happens, if you go to your Dice 1 Graph tab, look at that. You can already see it being recorded. So I already did it for you guys. Look at that, how awesome that is. Let's do it another time. This is our second time. Ooh, I got 6. Heck yeah. 1 time for 6. As you can see, if we go back to my dice graph, look at that. It's already being measured as well. Let me do one more time just to show you guys. This is my third time. Give me something good. I have a 5. And the same thing is happening is recording my data. Now, I'm going to keep doing this up until 20 times. I'm going to pause the video right here. And so the next time you hear me, it's me already doing the 20 times, okay? So I'll see you guys after I do it 20 times. And you should do it 20 times as well, okay? So I'll see you guys in a bit. Okay, so as you can see right here, I have my data right here. This should be totaling to 20 different times. So I have 1 plus 3 is 4, plus 5 is 9, plus 3 is 12, plus 3 is 15, plus 5 is 20. So 20 total times. And as you can see, my dice right here, my graph, boom, look at that. Look how beautiful that looks. Not super great, but that's how it looks, right? So for my other people here doing this, it's a pretty easy way of doing it. All you got to do is just roll the dice 10 times twice. So boom, 10 times, boom, 20 times. And look at that. You already have your data right here in a really nice bar graph as well. The only bad thing about this bar graph is it doesn't have the x-axis or y-axis labels or a title. So use the one I have. Use this one right here, okay? So you can just transfer the data here, and then you can see the dice, right? So we have rolled it 20 times, right? All right. Now, I would like for you to put a title right here. A title that goes according to the question I gave you. So I'm about to ask you a question and put the title that corresponds to that question, that best corresponds. Sorry, I'm gonna give you a question and click the title that best corresponds to this graph. Okay, so I'll give you a chance. Yes. So hopefully you chose that's basically the same thing we have on this part right here. Oh, I think I froze. Oh, the rolling dice probability. I'm literally just gonna copy and paste it. Right? Work smarter, not harder. Oh, reload. Oh my gosh. Let me make sure it reloads first. All right, technical difficulties. Internet, Wi-Fi, am I right? So here's the title, rolling dice probability, 1 dice. That's all you need to do for that title. Now let's go to our x-axis right here, right? What's a good label for this? What's a label we should put here? Yes, basically the same thing as our table right here. Number rolled. So I'm about to put that as well here. Number rolled. Awesome. That's our x-axis, our independent variable, what we're testing. So what is our y-axis? What are we recording? What's our dependent variable? Good job. Same thing. Same thing. Frequency roll. How many times that number got rolled? Frequency rolled. See? Now we have a beautiful graph right here. Isn't that awesome? Look at our beautiful graph right there. Sweet. Very good job, guys. Very, very good job. Now, let's look at this. Now let's go to our next one, okay? Now let's move on to this one. Now we're gonna go from 1, boom, to magic. It was magic. 2 dice, okay? 2 pair of dice. Now, with that being said, now our totals are gonna differ because now we're gonna add them together. So our probabilities change. So the lowest number I can get is a 1 and a 1. That makes a what? It makes a 2. And the highest number I can get if I add them together are 6 plus 6, which is what? Indeed, 12. I think it looks backwards. I think it's supposed to be like, I think it looks right. I don't know. So, but 12 basically. So now the lowest number I can get is a 2 and the highest number I can get is a 12, right? So, but now instead of rolling it 20 times, I want you guys to roll it 200 times. Wait, Mr. Castillo, are you crazy? I'm not going to spend the whole night just rolling 200 times. Fret not, guys. You guys can actually use the simulation. So if you press reset and you go to 2 dice, you can actually roll it 100 times. Just click it twice. So 1, 2. Look at that. Isn't that easy? It literally just recorded it for us. So what I'm going to do is just transfer my information here to my other one. As you can see, I won't get a 1 because I can't get a 1 with 2 dice. The lowest number I can get is a 2. So that's why 1 is not there. So I have a 6 for 6 times for 2 for 2. Let me just do this real quick. And yours may look different. Just know that yours may look different, okay? Yours may look different. But in my case, I have these numbers, okay? So yours may look different, and that's okay. It's chance. 1932. 7 we have. 2632 again. 26, 12, 11, 2. 26, 12, 11, 2. 26, 12. Oh, my bad. Oh, did I mess up over here? I think I messed up. 9. I feel like I messed up here. I have 6, 18, 16, 19, 32, 26, 32, 26, 12, 11. Wait, what happened to my 2, 3, 4, 5, 6, 7, 8, 9. Oh my gosh, I forgot to add a 10. Oh my god, I forgot the number 10. Hold up, guys. Hold up. We need a break around that. Hold up. Let me add 10. Okay, guys, thank you for your patience. Or not patient because I just paused the video, but I just fixed it. Okay, so now this makes sense, okay? So now these are my probabilities. I got all these numbers right here, my frequency roll. And so when I look at the dice 2, now you see I have different options. The lowest I can do is 2 and the highest I can do is 12, right? So these are the numbers I have right here. So, and for my titles, they're basically the same thing, right? So now I have rolling dice probability, but this time I put 2 dice. Diego? Sorry, that was my dog. And so I'm going to go right here. And I'm going to just copy and paste that. That's my title. We know that the answer here on the x-axis is what I am testing. So that's my number rolled. Oh, misspelled it. And then for my y-axis It's going to be my frequency rolled. So how many times did I roll it? Boom, there you go. Nice, right? Now let's go to the third one. Now we go from 2 dice. Now we're going to go to 3 dice. 3 dice, right? So now we're going to go to 3 dice. Now this one's also different. Oh my gosh, just spit. Sorry, guys. This one's also different. You get so excited, right? You just get so excited. Now it's the lowest number I can get is 3 because now I have 1. The lowest numbers I can get on each die is 1. So what's 1 plus 1 plus 1? Exactly, it is 3. And the highest number I can get is the highest for each die. What's the highest number for each die? 6 plus 6 plus 6. Good job, 18. But instead of rolling it 200 times, now we're going to roll it 2,000 times. Mr. Castillo, that's a long time. I got you. Go to your roll simulation, click reset, go from 2 dice to 3, and do 100. Just do it 20 times. And it actually tells you here how many rolls it is. So 100, total rolls 100. So just do it 19 more times. So 20 times total. How many clicks was that? 900. Sweet. Okay, 1700. Oh my gosh, I went too high. I went too far. My bad. I'm going to reset this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sweet. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Boom, look at that. Now I'm going to transfer all that data. Like I said, 1 and 2 are not there because you cannot get a 1 or a 2 with a 3 dice, okay? So let me transfer that data. Now I have 1432. I'm going to pause myself here and just transfer data really quickly because it took really quite a bit of time and the video is already long. Boom. Now I have my numbers right here. And if I look to the dice 3 graph right here, boom, look at that graph. Same thing applies here, guys. Same thing applies, right? So if I click right here, I know my title is now the rolling dice probability, but now it's going to be 3 dice. Oh. Boom. I know that my x-axis, my x-axis is number rolled. Oh. And my y-axis while I'm recording is the frequency. How often do those numbers come up? Let me spell frequency. Frequency rolled. Boom. And there you have it. Now we have 3 different pieces of data, right? Look at that. And it doesn't seem like there's a pattern to it, right? The only difference I can see is between dice 2 and dice 3. It kind of makes like a hill. You see like a little hill. Woo! And then on the second dice, also like a kind of like a little hill. And then the one is just cray cray. So you've done those parts, right? Now you're going to get to do your last part. Your last part is your claim, evidence, and reasoning statement. So the question is, when you rolled the 3 dice 3,000 times. So when you roll the 3 dice 3,000 times, no, 3,000 times, 2,000 times, my bad. Should be 2,000 times, not 3,000 times. There you go. When you roll the 3 dice 2,000 times, what numbers were most frequently being rolled? Okay. Yes. What numbers being rolled? Yeah, right? So your question is, when you roll the 3 dice 2,000 times, what numbers were most frequently being rolled? So your claim, what's your answer? Tell me your answer. So this is based on my data. So this is my data. So you cannot use this data because it's not yours. It's mine. So you have to use your own data. So what of these numbers were these numbers, which ones were rolled most? So what numbers were most frequently being rolled? So that's your claim. Your evidence, you already have your evidence. Your evidence is what? Your evidence is your graph. Use your graph to provide evidence. And what's your reasoning? I keep doing that, my bad. Your reasoning is right here. You're justifying your evidence. How do you know that those numbers are being rolled most often? Well, if you click on this image right here, there's a little link right here. Click on that link, and it's going to take you to here. And actually, it's going to help you a lot. Hopefully, you can read that. I'll give you an example real quick. On the 2 dice, if you got a 1 and a 2 and a 2 and a 1, that's 2 times. 2 times that the number can be rolled with the 2 dice. So if I have 2 dice and I want to roll, for example, a 4, I have 3 different possibilities to do that. If I want to roll a number 7, I have 1, 2, 3, 4, 5, 6 different chances of rolling a 7. So there's a higher probability of rolling a 7 than there is with a 2 or a 12, because a 2 is only one way, 1 1, and a 12 is only one way, 6 6. So hopefully that's with 2 dice. Now we're focusing on the 3 dice one. So let's see if that helps you out. Maybe you guys probably know already the answer. But yes, write your claim, evidence, and reasoning here, and it's gonna pop your chance to answer is gonna pop right here. Yes. So hopefully you put your answer in that short answer response on Edpuzzle, but you do not need to turn in this Google Sheet. You don't need to turn it in. It's just for you to be able to organize your work. Okay, so you don't need to turn it in. The only thing you need to turn in is the Edpuzzle. So make sure you complete the Edpuzzle. Okay, but yeah, I'm just gonna stop talking now. This was your lab. Hopefully you enjoyed it. I think chance and probability is super, super wicked. I love it. But it's a great way for us to keep organized with your data representations, your graphs, figures, and tables, and your CER statements, claim, evidence, and reasoning. Okay, so that is everything I have for you guys for today. I hope you guys have a great rest of your day. Let me know if you guys have any questions on Piazza, on email, or on Google Classroom, or on Google Garden. Okay, love you guys. I'll catch you guys later. Adios. Boop, boop.